Welcome to the channel of Seekers. In this session, we will study displacement reactions, double displacement reactions, and precipitation reactions. Let's see the video of displacement reaction taking place between zinc and hydrochloric acid. When we put some zinc granules in the test tube containing hydrochloric acid, reaction starts instantaneously and bubbles of some gas begin to evolve. Dear students, can you name the gas formed during this reaction? Yes, it's hydrogen gas. Can you state any three properties of this gas? Yes. Number 1, it's a colorless gas. Number 2, it's a odorless gas. Number 3, it's highly combustible gas. That is why we use burning splinter test in order to detect the presence of hydrogen gas. When we take burning splinter near the mouth of the test tube containing hydrogen gas, it burns with popping sound. Let's write the chemical equation for this reaction. Zinc plus hydrochloric acid, forward arrow, zinc chloride plus hydrogen gas. Let's see another example of displacement reaction between iron and copper sulfate. You can see the blue solution of copper sulfate in the beaker. When we add some iron fillings in the beaker, chemical reaction starts. And after some time, whole blue color of the solution turns to light green because all the cuprous ions from the solution are displaced by the ferrous ions, and brown colored copper metal gets deposited at the bottom of the beaker. Have a look at the chemical equation of this reaction. Iron plus copper sulfate, forward arrow, copper metal plus iron sulfate. Now let's try to define displacement reactions on the basis of these observations. The reaction in which an element displaces another element from its salt solution. In order to understand the concept of double displacement reaction, let's have a look at the video clip of reaction between lead nitrate and potassium iodide. This test tube contains aqueous solution of lead nitrate. When we add few drops of aqueous solution of potassium iodide in it, yellow precipitate of lead iodide is formed in quick time. Now have a look at the chemical equation of this reaction. Lead nitrate plus potassium iodide, forward arrow, lead iodide plus potassium nitrate. Let's see another example of double displacement reaction between barium chloride and sodium sulfate solution. We have taken barium chloride solution in this test tube and now we are going to add few drops of sodium sulfate solution. As soon as we add this solution, white precipitate of barium sulfate is formed, and the chemical equation for this reaction will be barium chloride plus sodium sulfate, forward arrow, white precipitate of barium sulfate and sodium chloride. Now we are in a position to state the definition of double displacement reaction. The reactions in which ions are exchanged between the reactants are called double displacement reactions. Now precipitation reactions. Just a short while ago, we have seen two examples of double displacement reactions. Number 1, the reaction between lead nitrate and potassium iodide in which yellow precipitate of lead iodide was formed. And second, the reaction between barium chloride and sodium sulfate in which white precipitate of barium sulfate was formed. Now question arises, what do we mean by the term precipitate? It's an insoluble solid substance formed in the solution during a chemical reaction. The precipitate exists as fine insoluble solid particles in the liquid to form a suspension. Because size of the fine solid particles of precipitate is greater than 100 nanometer, that is why they remain suspended in the solution. Precipitate may have any color. For example, the precipitate of barium sulfate is white, whereas the precipitate of lead iodide is yellow. Now let's define the precipitation reaction. The reaction in which fine insoluble solid particles or precipitates are formed is called precipitation reaction. For example, in the double displacement reaction between barium chloride and sodium sulfate, the white precipitate of barium sulfate is formed. And during the double displacement reaction between lead nitrate and potassium iodide, the yellow precipitate of lead iodide is formed. Dear students, that's all for today. Keep on learning, keep on practicing, and have a nice time.